Okay, so direct variation is going to be a type of equation that we are going to be looking at. This next unit is on writing equations of lines. So a direct variation is an equation that is a special equation in the form of y equals kx. K is called the constant of variation. It is also the slope of the equation. So this looks very similar to y equals mx plus b, except for we don't have a b because, this last part here, the graph of a direct variation always passes through the origin, so our b would be 0. And the reason why it's not a m and it's a k instead, it's because it's a constant variation, okay? And a direct variation equation, the reason why it's a constant variation, as one increases, the other increases. So like as x increases, y increases. As y or x decreases, y decreases. Okay, they have a direct relationship to each other. Okay. So determining a direct variation from an equation, you put the equation in y equals and determine if it fits the pattern y equals kx. So it's going to be y equals a number, then x. Okay? So are these direct variations? This is y equals x. What number's in front of x? 1. So this is y equals 1x. Is this in the form of y equals kx? Yes. All right, so the next one is y equals x over 2. What's in front of x? 1. So this could be rewritten as y equals 1/2 x. So is this in the form of y equals kx? Yes. Okay, the next one is y equals 2x minus 1. No, because of the minus 1. Direct variations do not have a b, a y-intercept, because the y-intercept is 0. Okay, so this one is it solved for y, so I need to solve for y before I will know. So y equals 3/5 x. So is this a direct variation? Yes. So we determine if something is a direct variation if it's in the form of y equals kx. Determining a direct variation from tables, you solve each ordered pair for k, so k is equal to y over x. If k is constant or the same for each ordered pair, you have a direct variation. Okay, so again, we're going to be solving for k, and k equals y over x for each ordered pair. Okay, so my first ordered pair is -6, 9. So k equals 9 over -6, and if I reduce this, that would be -3 over 2. Okay, so now I'm going to do my next ordered pair, where k equals -1.5 over 1, which I would have to make this into 15 and 10, and then that reduces to -3 over 2. We don't have decimals in fractions. And then our last one, set of ordered pairs, k equals -12 over 8, which again reduces to 3 over 2. So all of my k's are the same. So yes, this is a direct variation. All my k's, my constants, my slopes are the same, so it's a direct variation. Okay, let's determine the next one. If it is a direct variation, again, I'm going to be using the equation k equals y over x. So I am going to have k equals 1 over -2, which is the same as -1/2. Our next one is k equals 6 over 3, which equals 2. And our last one is negative 4 over 8, which is negative 1/2. So my k's are negative 1/2, 2, and negative 1/2. Is this a direct variation? No, because my k's aren't the same. Graphing direct variation. We always know one point on the line. It's going to be the origin, 0, 0. So that's where we're going to start, okay? Just like when we were graphing y equals mx plus b, we started at our b. Our b in this case is 0. So we're going to start at 0, 0. We're going to use k as the slope to get the additional point. So k is our slope, so k is the same as rise over run, which that means that we are going to be going up or down, then left or right. We're going up, it's positive, it's going down, it's negative, left is negative, right is positive. It's not something new. All right, so let's try graphing these equations. So I'm going to draw my graph. If we're drawing graphs on our homework, make sure that we use graph paper. Makes it look neater. So I'm going to start at the origin, because that's always going to be our first point. We always know if it's a direct variation equation, it passes through the origin. Then I need to determine my slope, my k in this case. It's going to be negative 3, and I'm going to put it over what? 1. So I'm going to go down 3, 1, 2, 3, and 1 to the right. And I can go down 3 more, and 1 more to the right. And then I can draw my line like that. Or I could have gone up 3 and 1 to the left. It's a negative slope, so we know it's going to lean to the left. Okay, let's try the next one. Okay, so we always start at our origin. And can somebody help me find my k? What do you think my k is going to be? 1 over 4. So there's a 1 in front of x, and it's over 4. Okay? So I'm going to go up 1 and to the right 4. 1, 2, 3, 4, and plot that point. Up 1 to the right 4. Plot that point. And then connect my lines. So writing direct variation equations. So we're going to be given an x and a y value, and it's going to ask us to write a direct variation equation. So what we're going to do, we're going to substitute those values for x and y in our equation. We're going to solve for k. But then we have to rewrite our equation with the k in it, and we put just x and y. We don't put the values in for x and y, because we want it to look like k equals a number x, okay? Or y equals a number x, sorry, not k. All right, so let's try this out. So my formula, or my equation, is y equals kx. So I'm going to substitute in my y and my x for y and x. So y is 12 and x is 4. I'm just going to put 4k because I know that when I multiply it's going to be 4k. You can change up the order. So now I can just divide by 4 and k is going to equal 3. So now I need to rewrite my equation where it's y equals 3x. Okay, so we're starting with y equals kx. What am I substituting in for y? 3. What am I substituting in for x? -9. I'm just gonna put, oh, okay, not x. My k. Then what do I need to do? Divide by -9. So I'm going to get k equals -1/3. So now what is my equation going to look like? Yep, y equals -1/3 x. Right, direct variation word problems. The first thing that we need to do is determine which value is x and which value is y. Remember, y varies directly with x. So x is the independent variable. Okay, remember that time is always independent? We substitute information into our direct variation equation and solve for k. So that's exactly what we were just doing. Then we are going to rewrite the equation with k. Again, exactly what we just did. The only part that's extra here is it says, if needed, substitute remaining information to solve for the required variable. Because sometimes they're going to have like 2 parts. First, we're going to have to write the equation, and second, where we're going to have to find a new number. Okay? So it says Mary's salary varies directly with the number of hours she works. Okay, so in my directions, it says, remember, y varies directly with x. So my salary is going to have to be y because it varies directly with hours, x. So if Mary's salary is 273 when she works 28 hours, write a direct variation equation relating to these variables. So my x is going to be 28 and my y is going to be 273. Okay? So we're going to have to write a direct variation equation. Y equals kx. So I'm going to substitute values in for y and x. So 273 equals 28k. We're going to solve for k. So I'm going to divide by 28. So k is going to equal 9.75. Now I need to write, it told me to write an equation. So I haven't written an equation yet. I need to write one. So my y equals what? 75x. Okay, because 9.75 is k. Now, so that would be like part 1 of my question. Part 2 is asking how many hours would she have to work to earn $351? So where am I substituting in 351 into? Not X.
Y.
Y, because Y is a salary. So 351 equals 9.75 X. So I'm going to divide by 9.75 on both sides. And what does my X equal? 36 hours.